Yes, hello. So let's factor this trinomial. And actually, I don't want you to think of it as a trinomial yet. I want you to think that when I say factor, the first thing I want you to do is pull the GCF if there is one. So first question is GCF. Is there one? So you're going to take this and you're going to pull the greatest common factor before you do anything else. And they all have a 5. And they all have an x. Whoops. So then you say, well, okay, let's pull that, and then we're going to continue factoring the remaining trinomial. So 5x times what is 25x cubed? 5x squared. 5x times what is negative 55x squared? Negative 11x. 5x times what is negative 60x? Negative 12. And then I have to watch my basic math. You have a calculator, so it's the end of the day. I'm kind of, I get slower as the day gets longer. So anyway, so now you're going to look at this and you're going to say, okay, how do I factor this trinomial if I can? So if this is section 6364, you definitely can. So we need to, the way I teach these is the steps, two. First we pull the GCF and then we say, what is it? Okay, if it's a trinomial with a leading coefficient, meaning the thing in front of the trinomial. Now you need to ignore that greatest common factor I pulled in the beginning. We're just looking at the trinomial now. And what I mean by that is if the trinomial starts like this, x squared plus 5x plus 6, this is a trinomial with a leading coefficient 1, and this is like section 6.2, I believe, where you simply say, hey, it starts with a 1, so I simply open, close, and I do an x, and I do an x. And then on this one, you would find your product. There's a product of 6. When you multiply those two numbers, you need to have a 6 when you multiply them. And the sum is 5. So I teach the basic ones this way. And then I play around over here. Over here, I play around with numbers that give me a product, that's a P for product, of 6, because when I multiply this one times this one, I need to have a 6. So in that case, so you mess around with these until you find these numbers that happen to work. So you have a 2 times 3 is 6, and 2 times 3 is 5. And that's what you then simply put them in here. They're both positive. And that's what a really, really simple basic trinomial. That's how you attack this one. But when you have a trinomial whose leading coefficient is not 1, meaning it doesn't just start with x squared, you need to do something else. And we're going to call this factoring by grouping. Some of you may know trial and error method or guess and check method. The book covers both. I teach the factoring by grouping because that's what most students do much better with. So let me erase this mess here. I go back and forth because I want to explain things as I go. Okay. So we've identified that this trinomial, and now let's make this here. Now let's make this previous 5x. So you see, this is just part of my final answer. This is not what I'm looking at when I'm looking at this blue trinomial. When I'm looking at the trinomial, I'm talking about these 3 items, this one, this one, this one. That's a trinomial. Leading coefficient, not 1, because that's a 5. Anytime you don't have a 1 there or just an x squared as the leader, you should probably do it the way I'm getting ready to show you. So I teach these that you're going to factor by grouping. So if the leading coefficient is not 1, factor by grouping. And what I mean by factor by grouping, well, when did you group before? In a previous section when we first started factoring. But you had 4 terms. When you have 4 terms, you can group. That makes it easy. Well, I'm going to create 4 terms. So we're going to call this over the top method. But you can call it what you want, but that's how you should approach it. So we're going to go over the top. What we're going to do is we're going to take that 5 and that negative 12, and we're going to come over here and say, here's my product, here's my sum. And in the top, I always put my product. What is 5 times negative 12? Negative 60. So you multiply the 5 times the negative 12, that gives you negative 60. You say the sum, that middle term here, when you add them together, like if you were foiling and you're combining like terms, you get a negative 11x. So in reverse, so then you're going to say, well, I need a sum of negative 11. So you have to find two numbers that give you a product of negative 60 and a sum of negative 11. Now you can say, hey, 10 times 6, one of them has to be negative, one positive, maybe this and this, or this and this. But when you multiply them, you get the 60. But when you add them, you don't get 11, no matter what you do. So then you mess around with this a little bit. You might dig a 3 and a 20. 3 times 20 is 60. One would have to be positive, one negative, or vice versa. It's not going to get you to the 11 that you need. So you mess with this a little bit, and you get better at this, playing with these numbers. And at some point, you're going to decide, hey, 15 times 4 is 60. 10 times 4, right? 40, and 5 times 4 is 20. So there's your 60. And then you have to think about signs. Maybe if this were a negative 15 and a positive 4, when you multiply them, you get a negative 60, true. And negative 15 plus 4 is negative 11, true. What you do with these two numbers, you don't put them in any parentheses or final answer. This is not a final answer. We're going to split this middle term. So if we're going to factor by grouping, we need 4 terms, don't we? So we can have 2 and 2 and group them. So I'm going to create 4 terms. What I do is I leave the first one. I split the middle one into these two things that I found. And then I leave the last one. And this is why I like doing the arrows, so I don't forget to bring something down. So essentially, ignoring that 5x that I pulled earlier, that gray one here, that is part of our final answer, but I want to ignore that one kind of right now because I'm trying to factor this trinomial. But so the question is this, and I know I over-explained, but is this thing here the same as this? And then you just check it. Negative 15x plus 4x is negative 11x, true. So now you have 4 terms. What do you do with that? You just go back and double bubble. That's how I teach it in class, so you don't know what I'm talking about. Okay. If I group, you can just call that double bubble. I don't like to use parentheses the way the book does, or any book does, or anybody else does, because they use parentheses and then it looks like multiplying, this parentheses, and then they want to multiply stuff. I call this double bubble. I group this thing together, and then I group this thing together. And so I have 2 groups. What do I do? From each group, I pull the GCF. So I'm going to say 5x times what is 5x squared x. 5x times what is negative 3. What 5x times negative 3 is negative 15x. So if you check this, right, you pull the greatest common factor, the 5x and the 15, 5x is in both the 5x squared and the negative 15x. Then you bring this sign down and you say that's a 4. And then you say, well, there's a 4 inside both the 12 and the 4, right? So you pull the 4, and then you say 4 times what is 4x? X. 4 times what is negative 12? Negative 3. So when you factor by grouping, you should have the steps already down, that from the first group you pull the GCF, from the second group you pull the GCF, and then you say these two are common factors. Actually, you have 2 big terms now. That term and that term, and now those 2 terms have something in common. It happens to be a binomial, and then you put your leftovers right there. So I always tell my students, pull that greatest common binomial factor forward, and then put the leftovers in the next set of parentheses. And then for final answer though, you don't want to forget this guy. He did exist. And that's just him being the greatest common factor out of the original, all of them. But I really wanted to show you the factoring by grouping. So we group double bubble, and then I kind of want to just say here, you know, steps from 6.1 really, isn't it? Where you, that's what I just explained, you know, you group them, you pull the GCF from each group, and then you pull the greatest common binomial factor from the two sets right here. Okay, so let me try another one. And I look really tired, but I'm just really tired already. Day starts at 4 in the morning. It's a long day. I need a mouse. I'm trying to scroll. Oh, I need to just erase everything. Clear. Okay, so let me see. I'm just using this as a background now. I need to find another example. Hey, bear with me for just a second. I had one earlier. Because if I use an example that was sent to me, I'm doing the most good, I hope. Just a second. There it is. So I had this question earlier today. Oh, I'm so slow. So again, if you see a trinomial, you don't immediately say, do I go over the top? Is it simple? You know, you should always ask, is there GCF? So you're gonna, anytime I ask you to factor, you should see if there's a GCF. And do you see how they all have a 4? And then let's use a bracket. 4 times 3x squared. 4 times negative 1x, right? Or negative x. 4 times negative 4. And then you're going to try to factor just that trinomial. And I'm going to this time do it on the right over here. And oh, I don't know. Let's do some green. So let's take this trinomial. You're going to say, hey, this is a trinomial. My leading coefficient is not 1, it's a 3. So you're going to go over the top. We're going to say, I need a product. I need a sum. The product is the 3 times the negative 4, which is negative 12. The sum is a negative 1, because the coefficient of that x term in the middle is really a negative 1. Then I'm going to find 2 numbers that make that happen. I need a negative 12 when I multiply. So how about a negative 4 and a positive 3? Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1, true. So these are the 2 numbers I use. You're going to split this up, like you're going to split these 2 up. And here you're going to say, hey, I have a negative 4x plus a 3x. And now these 2, you check them and make sure they bring you right back to the negative x. Okay, and then I have 4 terms. What do I do with 4 terms? Double bubble. So in the first group, I see they have an x in common, really nothing else. So x times 3x is 3x squared. X times negative 4 is negative 4x plus. Now, do you see how there is nothing here? And if there's nothing here, oh, you probably would have put the 3 close to the 4. See, I'm tired, so I didn't see that. But I'm going to actually do both. If there's nothing here, maybe you could pull a 1. That's kind of what you're forced to do now. 1 times what is 3x? 3x. 1 times negative 4. And now you have a common binomial factor. You pull that forward. And you put leftovers. I call them the leftovers. The x and the plus 1 in the second set. Now, and then for your final answer up here, it'd be 4 times 3x minus 4 times x plus 1. So we don't forget this original GCF. Now, I do want to show you this actually. I put them together weird. Usually I watch that, you know, like when I did my grouping. You see, that's what happens when you're tired. It's not wrong, it's just less, you know, it's a little more complicated, it seems like. Then we have a positive 3x and a negative, so you could have put the 3 closer to the 3, negative 4x minus 4. You see, this is the same thing. I use the same numbers. And then you double bubble. And I just want to show you it doesn't matter which way you do it. And I'm not lively today. Usually I make jokes and I try to be funny, but I'm just kind of tired. So 3x times x, 3x squared, 3x times 1, 3x. Negative 4 times x is negative 4x. And then here you just have to watch your sign because you don't bring this one down. You ask negative 4 times what gives you negative 4, and it's a x plus 1. There's an 1 right there. Negative 4 times positive 1 is negative 4 true. Now you have these that match. You pull them forward, and you have your leftovers, in this case, 3x minus 4. So anyway, does it matter? A times b is b times a. It's a commutative property of multiplication, so it doesn't matter. So just real quick, one more time. Do yourself a favor. Don't use this method if you have something simple like this. Whoops. I just want to show you that don't do that. Oh, what did it do? It went to a mouse. Ah, the pen has buttons. That could make it faster. Okay, so if you have something like this, I call this in class a simple trinomial because you see the leader is technically a 1. On those kind, I tell students don't do this. You can do over the top and you can, you know, go a long way. But what you can do is just open, close, because x times x is x squared. You still have a product. In this case, it's just that 12 there. And you have a sum of negative 7. And then you say, what do I use? Negative 3 and negative 4. Negative 3 times negative 4, positive 12 true. Negative 3 minus 4, negative 7 true. And then you simply put them in there. So I call this a simple trinomial. If it's like this, simple trinomial, you simply put those things in here. You don't do the extra 2 steps. If you do over the top, you're going to have an extra step, and they're really unnecessary on something that starts with an x squared. So anyway, thank you. I will see you later. Hopefully I'll be a little more entertaining next time.